So all credit goes to these two, Dr. Santillia and Dr. Sanchez. And with that, we're going to start following over here. So we should be good. Okay. So we're going to start off with going back a little bit because I figured out where these two equations came from. Took a while, but figured it out. Over here, if it loads in, hopefully. Oh, not there. If it loads in, come on. Yes. Yes, over here, these two equations. I was shocked to where they came from. They're not. It's not obvious. It's not hard, although. Yes. So let me just really quickly show you where they came from. Yeah, a quick Google search was all I needed. And this is from Dr. Sanchez's textbooks. This whole entire PDF. So we're using his textbook to figure everything out. But let me just write over here what the whole entire meaning of this whole thing is. Okay, so we start with P equal, that's pressure, density, RT. We know that equation really well. We have, constant, and then we use the fact that H equal EO plus CPT. It's important. Where does that come from is the question is asked first, right? Now you have to understand the definition of entropy is just given. Like entropy is just a definition that is commonly used. And I'm just going to use it right in a different way because I like it right in that way. No, because it's confusing. I have no idea. But we know that P over density equals RT, right? So this is equal to P over density negative 1. So we can move that RT over here. And then we have H equal E plus RT, right? Yeah. And then we know that dE equals CV dt, right? Yeah. So, yeah, that's where we integrate this, right? We integrate this integral dE CV integral dt, which equals E equal EO plus CVT, which, yes, I just realized where that came from. Yeah, that's not a good sign. And then where that goes into is basically, notice that this can go to here. So H equal EO plus CVT plus RT. Yeah. Now here's the hard part. Notice that H equal EO, we can do plus CV plus R parentheses T. Now this is equivalent to saying CP because R equals CV plus CP. And I realized I never explained what CP or CRRB mean. These are specific derivatives, basically. Now that is the first thing. The second thing I need to explain to you is where the other equation comes from, the entropy relationship equation, which comes straight from Gibbs equation, which is TdS equal dE plus pressure D 1 divided by this. That's Gibbs equation. A specific type of Gibbs equation where pressure is not differentiated too much, but so what that gives you is that the P this TdS equal dE plus no, take a derivative of that, and that should give you plus P parentheses D density divided by density. And now you're getting the point over here where we see TdS equal, actually no, we have to put those into CV dt, you know that. And this goes into minus RT d rho t minus R ln of rho. Now we use here, we use T equal P rho R. So what that means is that we can shrug it in here, basically. But what does ln of T give? That equals ln of P minus ln of rho minus ln of R. So what that gives you is S minus SO equals CV, parentheses ln pressure minus ln rho, am I correct about rho? Yes, minus R ln rho plus a constant. Now, we see that using, and from here, the important part is that from here, if you simplify by using rho equal, because CV is still, well, that doesn't really help, does it? How? Because this doesn't form, this does not work. Because this equals negative CP, which is not CV. Yes. My problem here was not using gamma. Gamma CP CV is what I'm supposed to use. So what does this mean? We technically already have it here. We just have to get rid of this term, this R. So which is harder said than done. we could then do this. We could do ln of PCV plus ln of rho CP, and the constant doesn't really matter. So ln of PCV multiplied by rho CP. Does that give me anything useful? No. Because we can show it soon. But this was the right direction, definitely. Even if it doesn't look correct, it is the right direction. Because we get CP here. And if we do CP like this, we get these two on top. And then we could switch it up, and I got something wrong. That's why I couldn't get it. What I got wrong is over here. This formula shows this, right? But that's not true. It's minus. Is this. There we go. String. That's the reason I got it wrong. And somehow I got this part right. I just fucked up this. So that's why there's supposed to be, what is this? A negative here that trickles down here to be a negative here, which is negative here, which is negative here, which then turns this into CV ln PCV divided by rho alpha. No, that CV goes away, and there we have it. That's S minus SO divided by CV. No, SO, and then you divide by CV on both sides and get that. Okay, we got it. Well, which basically comes from definitions. So two definitions you need to know is, I guess, something here. This definition is used everywhere. And I guess somehow this, I never memorized this, but now I think I might need to. H equal E plus P divided by rho. I never thought I had to memorize that. This is Gibbs equation, which I guess you should memorize. I really don't know if you should. Well, now we have thoroughly broke my brain with this. This was thermodynamics, which is always hard for me, so it broke my brain a little bit in ways I can't remember. I'm just joking. Anyways, with the we were on this topic, which is a double tensor. Yeah, so we move on to here, which we're just gonna have to figure this out because this was one of the weirder ones, I must say, that I've never seen before. This equation over here. I've never seen this before. No, I just derived it yesterday, but I never seen it used like this before yet. So we're gonna have to do this, which yeah, we have discovered these two last time. Like these two are easy because I've done that in 210B. Yeah, these are done. These are doable. This one is hard because I've never done it before. Now, and yeah, we have to be done. To be fair, we done an A2, so yes. Okay, so now let's just figure out how to do those real quick. I don't know what the usefulness criteria here is, but we'll figure out why they're using it soon. So this professor knows what he's doing, is what I'm saying. So let's just trust him. So we have density, we have temperature, we have a velocity, and we have dot S equal tau double bar dotted with oh, this is gonna be hard. Okay, and then we have a plus. I'm looking it up as usual. So these this one I don't think I can do either. So we're just gonna have to figure this out. And density, I think you just do density infinity, right? Temperature, velocity is the length divided by time, which no, it's u infinity because we have that u infinity. Over here is going to be a delta S divided by, because we can do relative, R, because that's a scale length. We got that order. Now we don't know what the order of this is. I am very confused by it. I don't know what that could be. It gives you it, but I want to figure it out. Obviously, there's a u infinity from here. And I know from this tensor that in reality, it turns into this format, x squared, go on, whatever. So this has to be squared, and there has to be an r squared here. There's an L from there. Now, is that all? That's the only thing I can figure out. Oh, wait. There's also a mu here. Don't forget that one. That's the only thing I know. So that's the whole check mark over here. Over here. Wait, is that the tensor? Same tensor? No. Yes. Well, yeah, yeah, sure. K, I think it's just a material property, so just leave it be. And then there's a T, and then there's an R square, and there's a K, basically. And apparently you can do delta K, delta T, which is fair enough. I mean, it's a differential. So But that's not the real reason that there's a delta. The delta is because there's T infinity that you can just do a relative of, apparently. Yeah, because there's T wall. From this, what can you do? They then bring up um, this two stuff. Okay, I want to get the PDF open. Here it is. Rho equal P R G temperature, and then S minus S infinity divided by CV equal ln of P divided by P infinity divided by eraser rho divided by rho infinity in the parentheses by gamma, which I don't know why. Oh, they're just dividing by itself now? Okay, all I know is that it's due to this, okay? You can ask the prof. This is another ask prof moment. I have no idea what's going on, so I just ask prof. I don't know what's going on. So there's a boundary condition, obviously, and the boundary conditions are x bar equal r, and then v like this equals 0, and t equal t wall. And then we have this x bar, and this is so much greater than r, and this is v equal u infinity e x this, and then t equal t infinity p equal p infinity. There we have it. There's another thing, which is this is r, and then this is t wall over here, and then yeah, that's basically the oh infinity like this, infinity u infinity, which yeah that makes sense. T infinity and p infinity, yeah that makes sense. Yeah, everything there checks out. Um, Now Reynolds number is next. Of rho v this dot this v o parentheses tau ij equal rho infinity u infinity r mu. Why? And this should simplify the equations of pressure. Okay, so well, I think I get it. This is just going greater than this is 1 2 1 10 2 2 210b. So this is going greater. This is just going big as huge. And well, from that bigness, what can we electrifyingly get? Um, this shows the difference between in viscous and viscous, right? Um, now I can move over here and see which of those two are more. So this is going to be divided. So it's going to go downwards, and this is going to go downwards. Ah, so all that's left is this middle portion. Okay, I get it. Middle portion. Get it? So all we have to say is that middle portion is king. The middle portion over here is king. So we go over here, back over here, and we go over here to this, and then we just say this rho v bar dot v like this, similar negative rho p this. So we have that. So what does that even give me? Rho v dot v equals to negative this pressure. Okay. From this, I can figure out the approximation apparently, which is fair. Yeah, that's true. We know that this is approximate with p, and then there's a length scale of r. So this estimates to delta p. This is delta, not gradient. And that's why I have to be careful. Is somewhat proportional to infinity u infinity 2. Okay, I'm not sure if the professor was equal to, so I'm going to assume equal to, but not sure. So yes, okay. It is interesting to compare the difference with ambient infinity according to. Okay, so divided by the ambient. I don't know why you would want to divide it by ambient, but the professor says there's a believe the professor, because the professor is like way more smart than me, like 200 times more intelligent. P infinity, right? Now this over here needs to equal gamma and then u and a. Why? No idea. How? No idea. Why? No idea. So we're gonna have to figure all of that out right now. What? How? What? No? What? Okay, so I'm confused because there's a big jump over here in the touch. um, how? How the fuck does this work? It has to be some kind of property of this. There's U infinity, so this must be true. Oh, this is the reason why. Then we just find an equation that has this and A and rho, which I think we have. No, we definitely had it. No, we definitely did have it. It's over here. It's over here. It's over here. Beautiful, beautiful, beautiful. Now I remember. And it's this equation over here. That's the kingpin of everything. I 1.11 and use that over here. So it's like equation 1.11 and put it here. So I got it. Okay. Okay, I got it. Okay, so what you need to realize that I didn't realize until now, this equals rho infinity and p. And then this u infinity goes straight through. Now remember, a equals the square root of alpha p infinity, I think, divided by p, right? So p infinity. I think, right. Yes, I think that's true. So we can say a squared equal alpha p infinity p. This is wrong. This is right. Oh well, I don't know. We can plug this into here. See this? So p infinity. No, no, that's right. So that gives you rho. Oh, this is rho. So the bottom is rho. So to flip it, so that is equal to rho. No, this is equal to, yeah, this is equal to rho a square. So that's rho a square, and that's infinity. And we are ching. Beautiful, beautiful. That took forever. The final version of that. So that's beautiful. Um, there's not much to say about that, but we got it. So we move on. We have this. Yes, that's a square, and then these two goes away. So that's a check mark there. Um, next we have to go to this format over here. Oh, that is, what the hell is going on there, you may ask. Um, huh. You get this from that? Now that's interesting. That is very interesting. That shows something that I never thought I would see. Um, and furthermore, you see Prandtl number. Holy crap! I never thought I would see Prandtl number here. Okay. All right. Let's continue. Prandtl, very famous guy, very powerful in the field, very well verbose in the field. Like he's a veteran of this field. Ooh, like, yeah, legends never die, right? um, and that's to people looking at the PDF. Sorry about that. This is something new. I thought this was something I learned in 113, but this is completely different than that class. This is like next tier hard. Alright, so acceptable compressive effect is when m infinity is greater than 1, right? And the flow, whereas in the flow with m infinity less than 1, the result is special difference. So I think we're trying to get the two different things over here because I see but this is my understanding. It might be wrong, but here's my understanding of Mach number. So let's start with this over here, which is basically density infinity, temperature infinity, V infinity, U infinity, or whatever you call it, and delta S divided by the length scale, which is R. Okay, we have that. We have this one, which is going to give you, um, what was it again? Tau is the U, the U infinity square divided by R, obviously, and then there's another R. Or this can't be R cubed. So mu here, it's R cubed. No, it's R squared. Um, okay. I'm confused now. This tensor should show up as d squared dx squared u, right? No, no. It's like this. Yes, okay. Because it's tau dx dy. Yeah, that makes sense. Yes, that's correct. And this is true. And we have this over here that has k over here with r squared and delta t. Do I understand why there's delta over here and there's t over here? No. And I will never get it until the professor tells me, so we're not even trying. No, we should try. We should definitely try. Why is there a difference? So no, I don't actually know why. It must be the derivative, but I don't know why velocity doesn't treat it the same way. Maybe velocity is already a derivative. The length scale. Yes, because this is like temperature ambient, so it's a relatively in there. So yeah, okay, fair enough. Well, I'm trying to say it's relatively. If you do a derivative, the relative doesn't make sense because it's already changed. It's a change already, so it doesn't really make sense for you to get the t infinity. It doesn't really matter. Okay, we got it. We got the explanation. It was not that hard. Now we have density infinity, T infinity, U infinity, delta S divided by radius equal U infinity square mu divided by r squared. There's no reason for me to think Reynolds number should be here. And then these three over here should give you Reynolds number, right? U infinity squared divided by temperature infinity RE. That does give me something. And then we need to get it to what? What's next on the thing? Rho, and then CV. Huh. So we can convert temperature. So we already have a U infinity for a Mach number. We need another Mach number here. And then we also know that A infinity squared is equal to alpha RGT infinity, and all this are infinity, right? And we know another way to write RG is equal to CP which is another way, if you think about it, is equal to, I believe his rho equal, I believe it was called divided by CP or something, right? Yes, I believe that's it. So this will give me, let me check, it's rho minus 1 CV. Yes. From this, I can get this. So the temperature over there, T infinity inverse equals what? T infinity inverse equals something like this, something huge. A squared divided by rho RG, right? No, 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 no. It would be T infinity, think about it, and then we inverse that, so that equals alpha RG divided by A square infinity. And from that, A square, A infinity square, and then we have rho RG divided by RE. So then we have Mach infinity square, RG divided by alpha RE. So this has to equal CV. Does it? No, well, it doesn't. No, because this equals this. So we have to do infinity square RE, and we do alpha minus 1, and then this over here we divide by CV. So S minus S infinity, but we write CV here and divide by CV, so we cancel out. We'll just show that off. That was hard. Next one, we have this. The CP or CV again? CV again. Wow, it's always CV. It's always, let's say, it's hard. I must admit, you're right. I will not take that lightly anymore. Left hand side. Okay. So we need to know Prandtl's number too. So this is going to be a pain of that pain. Dot Vs proportional to V dot K delta T. Okay, we got that. So this is equal to, well, we'll discuss this, T infinity, and there's U over here, and there's delta S divided by R, and then this is equivalent to divided by R, K, T, delta, and then, is that all? Check mark? Square, we put the square. We got rid of the K, so we got, uh, hmm. We're getting very interesting numbers, I must admit, very interesting. So, got delta S divided by, we just leave delta S here and leave everything to here because this is the easiest way. Just figured that out last time. T infinity, and then U infinity. From this, I can figure out everything. Infinity, T infinity, R, U infinity. We know that T infinity, so delta T and T infinity goes here. There's no need to change that. And then we change this to PR, which then changes to, it changes this whole thing to mu CP, U infinity, R. And this over here is Reynolds number, right? So change this to CP delta T, Reynolds number, right? And then PR T infinity, right? Am I correct? CPS, I think I'm correct about this. And then you divide everything by CV, so delta S equals CP delta T, and then there's a CV, so there's a gamma over here, and we have 1 divided by RE, PR, and then there's T infinity here. Cha-ching, QED.